Good day, class. Let us now proceed with our next problem. In this problem, we're asked to solve the total moment about point O due to the given forces. Since we need the moment arm of each force to compute the moment, let us first outline their values. Let's start with the moment arm of 20 Newton force, denoted by D sub 20. By trigonometry, D sub 20 is equal to 3 meters times sine of 30 degrees, which is equal to 1.5 meters. Next, for the moment arm of 50 Newton force, let's denote it by D sub 50, which is just equal to 2 meters. Then, for the moment arm of 40 Newton force, let's denote it by D sub 40. By trigonometry, D sub 40 is equal to 2 meters plus 2 meters plus 3 meters times cosine of 30 degrees, which is equal to 6.598 meters. Lastly, the moment arm of 60 Newton force is simply equal to 0 because its line of action passes through point O, or the moment center. To have a practical solution for this problem, especially this problem involving several forces, let's recall the general formula of moment as discussed before. Then one by one, let's substitute the needed values. To start, let's write the first term as the moment due to the 20 Newton force, or equal to positive 20 times 1.5. Next, we add the moment due to 50 Newton force, or equal to negative 50 times 2. Take note again that a negative sign must be included if the force creates a clockwise moment above the considered point. Next, we add the moment due to 40 Newton force, or equal to negative 40 times 6.598. Lastly, we add the moment due to 60 Newton force, which is just equal to 0. So summing all these values, we have this negative result, or that M sub O is equal to 333.29 Newton meter clockwise rotation. If you are going to use this figure, you can draw the moment about point O due to all forces as follows. Now that you have an idea about the moment of a force, let's proceed now with the special case of moment, which is couple. Couple is formed by two non-collinear parallel forces having the same magnitude and opposite direction. For example, we have this rigid body acted by force F and by the negative of that force. Since these two forces are non-collinear, parallel, oppositely directed, and have the same magnitude, these forces can be pronounced as couple, and we can combine them into a single moment, also known as the moment of a couple. Take note that for this force system, the only effect that can be produced is the tendency to rotate, since summing these two forces will just result to 0. Also, the direction of the rotation of this moment can be determined by just observing the possible rotating effect that a given couple can produce. Now, if we let the perpendicular distance of these two forces as distance d, then the magnitude of the moment of the couple can be simply expressed as magnitude of the force times distance d. Before we prove this formula, let's take note first of the properties of a couple. First, for a couple system, the resultant force is 0, as explained a while ago. Second, the intended effect is rotation only. This means that a couple cannot produce any tendency to translate the body from one point to another. Third, the two forces can be replaced by a couple only, as shown in this example. Fourth, they can be added with proper sign convention. Fifth, the moment of a couple has no moment center, which follows that this kind of moment is considered as a free vector. In other words, this moment can be placed at any point on the body without altering the net effect. So let us now quickly prove the formula of couple moment and why is it considered as a free vector. Considering the same force system, let's use point A as our moment center located in between the two forces. So by summing moments about point A, we can express the total moment equal to moment due to the force above point A and moment due to the force below point A. By simplification, we now have m sub A is equal to force times D, which is the same to the formula of moment of a couple. To prove now that it is a free vector, let's use another point denoted by or denoted as point B. From point B, we can let y and L as the distance of the two forces. By summing moments about point B, we can express the total moment equal to F times Y plus negative F times L. If you factor out F, the total moment is equal to F times the quantity Y minus L. Based on the drawing, Y minus L is just equal to distance D. Therefore, the total moment about point B is also equal to the moment about point A and to the formula of moment of a couple. This proves that at any point on the body, the rotating effect of the couple is the same. Thus, moment of a couple is a free vector. Let us now apply this concept in a sample problem. In this problem, we're given the force system as shown in the figure, and we are required to solve for the resultant couple moment. In that case, let's just denote that unknown by variable m. By inspection of the given figure, you will notice that you can create three coupled moments. You can combine or replace the two F sub 1 forces into a single moment. In the same way, you can replace F sub 2 and F sub 3 forces with their corresponding coupled moments. To have a practical solution, let's recall again this general formula for moment. You can observe in the formula that each term can also represent the expression of each couple in the force system. So by substitution, the resultant couple moment is equal to negative 200 times 4 plus 450 times 3 plus negative 300 times 5. By summing algebraically all the couple moments, we now obtain a total value of negative 950. Therefore, the total couple moment in this system is just equal to 950 pound-foot clockwise direction. This means that in your drawing, you can replace the three coupled moments by their resultant. Now that you have an idea about what is couple, you can now study the concept of force couple system in the next part of this lecture. So that's it for now. Thank you, class, and God bless.